Alright, so in the previous video, we looked at two examples involving limits, but this one just comes with a picture, not the numerical table. So let's try this using the graph. Consider the function f given by f of x equals 3x minus 5 over x minus 2. Now, do you remember how to find the horizontal asymptote in pre-calculus? If the degree of the numerator and the degree of the denominator are the same, then the horizontal asymptote is the ratio of the leading coefficients, right? A's of n divided by A's of m. Okay? So the horizontal asymptote, using that rule, I think you remember that. You probably learned that in 161. The horizontal asymptote is at 3 over 1. That's why when you're looking at this graph, we have this, it's not visible, so that's why I'm going to sketch it myself. I'm going to draw this horizontal line at y equals 3, and that's what the end behavior will be doing, like to the right of this graph. You see, it's like a slide. If I follow this graph to the right side, if you keep on going, do you see that the red graph, this graph is approaching 3 to the right end? And to the left end, if you approach the left, negative infinity, keep on going to the left, it's going to get infinitely close to that horizontal asymptote at y equals 3. Okay? All right. So what are they asking us to find? Let's find the limit. Limit of f of x is, what's this saying? X approaches 3, either direction. So hopefully they're doing the same thing from the left to the left and to the right. So where is 3? So here's my 3. Let me go straight up and find the graph. Let me go straight up and find the graph. You know what? This graph is continuous at x equals 3. We have a point at 3. So from the left of 3, we're going to 4. From the right of 3, we're going to 4. And you know what I mean by 4? 4 is the y-coordinate of that solid circle, that closed dot. So that was kind of odd. I don't think that was a typo. Maybe I was trying to ask you to do 2. All right, but the answer is 4 because what they were asking you for was limit of f of x as x approaches 3. So at x equals 3, we had a point here. We did actually have a solid graph. Okay, it's a smooth graph. That means we have a closed circle. In that case, well, the limit is simply going to be its y value, 4. Okay, it's kind of, that was kind of a little bit easier, unexpected, because I wanted to do some like infinities and things like that. All right, what's next? Oh, here it is. Limit of f of x as x approaches 2. X approaches 2. Now let's take a look. Because 2 is where something funny is happening. Okay? 2 is where we have the vertical asymptote. Okay, let me sketch the vertical asymptote with a dotted line. Okay? This function is too scared to go to 2. Why? Because when x is 2, look, when x is 2, the bottom of the fraction will be 2 minus 2, 0, and you can't divide by 0 in math. So that's why we have a vertical asymptote at x equals 2. So if you look at the left end and the right, not the end, the left limit and the right limit, as I'm approaching this blue line from the left, I'm going down to negative infinity, right? But as I'm approaching this blue dotted line from the right, do you see that we're going straight up? So they're not doing the same thing. One is going down, the other is going up. So we're going to have to tell them that the limit does not exist. Because, and let's give them a reason, okay? The left-hand limit does not equal to the right-hand limit. And in fact, they're not even going to a real number. They're just going off to negative infinity and positive infinity. But then the answer for part B is it does not exist because the left-hand limit, the right-hand limit, they're not the same. Okay, how about part C? Let's look at this one. What about limit as x approaches positive infinity. Well, now what does that mean? That means look at the right end behavior. So to the extreme right, to the right side of this graph, what is this graph doing? If I'm following this graph to the right, to the right, to the right, can you see that it is approaching to the right? F of x is approaching y equals 3, that dotted orange line. So the right end behavior is 3. I'm going to tell them as x approaches positive infinity, f of x is approaching 3. How about the second one? The second one is asking, how about to the left side? So I'll tell them, look at the left end behavior. What is this graph doing to the left? Whoopsies. All right, let me take a look. To the left, if I keep on following this graph to the left, this is getting really, really close to this orange dotted line, but it's never going to touch it. So what we can tell them is it's approaching, okay? The limit is 3, okay? So we did do all parts of this example. I think I'm going to cut this because example 7 is graphing a piecewise function ourselves and talking about the limit. So that's a slightly different topic. So I'll go ahead and stop this video and come back for the very last one. Okay?